Hi everyone, Aman is here. In this session we are going to discuss how to run the structural model. When measurement model assessment is satisfactory, the next step is to evaluate PLS result in assessing the structural model. So first we need to run our consistent PS algorithm, as we have reflective model and we also want more robust results. So let's go to partially square. For the measurement model we go for the factor. We leave the iteration stop criteria default and run the calculations. Okay. After running a measurement model, we get the construct liability and validity measures, discriminate validity, collinearity statistics, model fit, and R square values, outer loadings, and all those. But the thing is that we are not sure about that. Some of our values are also less, and we are not sure whether these are statistically significant. You can see many of the factor loadings are less; they are below the threshold level of 0.7. So we are not sure that whether these indicators should be deleted because it might affect the overall construct variance. So in that case, we need to run the bootstrap model. And the thing is that there are some standard measures criteria which should be considered, include the coefficient of determination, R square, before going for the measurement model, structural model, and it should be good, as we have the structural model. So the R square of 41.6 is strong enough, and we have to check for the blindfold stuff also. In the blindfold procedure, it gives the blindfolding based cross validated redundancy measure Q square, as well as the bootstrap also check the statistical significance and relevance of the path coefficients. In addition, the researcher should assess their model out of sample predictive power by using another method, which is the PLS predict. Let's go for the PLS predict, and by assuming the sample size is large enough. Structural model coefficient for the relationship between the constants arrived from estimating a series of regression equations, but before assessing the structural relationship, collinearity must be checked once again to ensure that there are no collinearity issues. That is, you want to know that these constructs are distinct entities and they are not they don't overlap with each other in their concepts. So if we will see, we know the VIF values between 3 to 5 are also problematic, and the values above 5 are the indicator of probable collinearity issues among the predictor constants. Ideally, we should have the VIF values less than 3 or less, and as we have very good data because we got the ideal VIF and all the values are less than 3. But in case if there is collinearity issues are present, a frequently used option is to create high order models that can be supported by theory, as per here et al. Now, if there is no collinearity issue, the next step is examining the R square value of the endogenous construct. Then we will run for the R square value. We know the R square value is 41.6%, which is quite good for this cross-sectional study. Let's go for the bootstrapping technique. As we know that our data is in PLS, we don't take assumption of normality, so the so we cannot use other techniques which implies a parametric significance test as used in the regression analysis. So these tests cannot be applied to test whether coefficients such as outer weights, loading, and coefficients are significant or not. Instead, PLS relies on non-parametric bootstrap method to test the significance of estimated path coefficients in PLS, in which the subsamples are created with randomly drawn from the observations with replacement, and on the basis of these we got the parameter estimates like outer weights, outer loading, and path coefficients estimated from the subsamples, and they are used to drive the standard error for the estimates. With this information, t-values are calculated to assess each estimate's significance. So let's run our bootstrap, as we have If you use the plain PLS algorithm, you will go for the bootstrap technique. If you will go for consistent PLS algorithm, you will use consistent PLS bootstrapping technique. So as we have reflective model also and we want more robust results, we will go for the consistent one. Let's see what are the options. You can see this method run the bootstrap routine by using the consistent PLS algorithm. Bootstrapping is a non-parametric procedure that can be applied to test whether coefficients such as outer weights, loading and path coefficients statistically significant by estimating standard error for the estimates, and then T values are calculated to assess each estimate's significance. So let's go for the if you have used the consistent PLS algorithm, you can only go for consistent PLS bootstrapping. Let's go for the bootstrapping options. First option is the subsample. Let's study in bootstrapping. Subsamples are created with observation randomly drawn and with replacement, like from the original data you just draw up to 500 to 5000 samples and with replacement, and but obviously that would take long. So but for initial you can take 500, but final result is required 1000 number. You can go for the basic bootstrapping or the complete bootstrapping, and there is option for parallel processing because you have many subsamples that are running together. So we will take the parallel processing. We want computation time to be less, so we run them up in parallel technique. And then come to the confidence interval method. In this method there are you can either use their three options: percentile, standardized, and bias corrected and accelerated bootstrap technique. As we know that bootstrap with non-normal data can produce peak and skewed bootstrap distributions, and this can also be controlled with the use of bias corrected and accelerated bootstrapping technique, since it adjusts the confidence interval for the skewness. So we will go for the bias corrected. Okay, test type. The test type should be on the basis of hypothesis, that whether your hypothesis is one-sided or two-sided. In one day, if your hypothesis is directional, that is showing a positive relationship between suppose GD and WE, or negative relationship, then you will use this one-tailed t-test. Otherwise you will use two-tailed t-test if your hypothesis is like there is a statistical significant relationship which could be positive or negative. So in that case you will use two-tailed test. For significance level, if it will show the confidence interval estimate. So specify the significance level of confidence interval computation. As you know, for the human behavior we always take 95% confidence interval. So here the significance level is 0.05. Let's go to another window for the consistent partial least square. Connect all the latent variables. Come to partial least square option. Now in the structural model we are more interested in studying the path relationship. So we'll go for the path weighing scheme. Maximum iteration will be on default. Top criteria will still be on default. Okay, so I think just run the calculation. As you know, it will complete bootstrapping. It will take obviously longer than usual. Now we got the results for the path coefficients. You can see we got the p values, significant level values for all the for all our relationships. We can see the t-stats value also, which shows the parameter estimates, and if it's more than 1.96 at 95% confidence interval, then it is statistically significant, this relationship. Okay, we can see the specific indirect effects also. If there is no specific statistical significance values, it means there is no mediation effect. Okay, you can check the outer loadings. As you remember, we have some issues with the outer loadings, but we can see here also that all the outer loadings are appear significant. It means we don't need to bleed any indicator loadings. And you can check the R square value, is it significant also. R square adjusted if we have more than two independent variable. So all these are appear significant. You can check the value of ABE. As you remember, we have some issues with our ABEs also. So here they are showing that all those area variable, though they were less than the threshold value of 0.05, but they are still significant. Likewise, you can see the significance of composite reliability, interconsistency values, rho A, Cronbach alpha, and SRMR also. And let's see what is the path is showing now. Now you can see that instead of the beta values, now it's showing the t values for the indicators and for the path relationships also. Now we will conclude this session. We will in the next session we will discuss how to interpret our the structural model. So thank you for now. Thank you.